What are you doing? We're back. We're back. Woo! We've been away for a little bit. We took a hiatus in October, but we're excited to be back. So thanks for joining us tonight. Just as a reminder, we're the organizers of the Toronto Modern Data Stack. So myself, Lindsay, if we haven't had a chance to meet, and we've got Jonathan and June here, and Nassim unfortunately isn't with us tonight, but she'll be back for future meetups. Just wanted to take a minute to say thank you to Wave. So Wave obviously is hosting us tonight. They also, big applause. So thanks so much for having us in a very cool office. If you haven't had a chance, down at the end of the hall, there's a really cool area down there. So be sure to take a little tour. And then Secoda as well. So I work at Secoda, obviously. So we've got the Secoda team here with us tonight, and we sponsored the drinks. So give us a round of applause too. Okay, so our speaker sessions tonight, we've got 3 speakers. We're gonna go through, hopefully, lightning round a little bit. We'll try to keep things quick and we'll keep time for questions and answers. But we've got the Wave team up first. So we've got Jerry, who will be speaking about the evolution and challenges of the Wave stack. And then he'll be followed by Diana, who will talk about the data transformation layer. And then you'll get me back up here for a little bit to talk about cost containment. So, logistics. Ayaz, do you want to come up here and help me out with this? Yeah, so if anyone hasn't had a chance to find them yet, the washrooms are just outside the door here on the side here. And then I'll let you take this for the fire safety.
Yeah, as Lindsay said, washrooms are across the hall. Just make sure that you exit back into the same side of the thing, otherwise you'll be locked out. So there's signs there so you don't go through the wrong door. And then in case of a fire, in the unlikely event of a fire, the corridor, there's 2 exits, just follow the signs. There'll also be guidance from our team. And then just if we can make sure the pizza and beverage consumption stays in this room in the junction where you got it. And there's a lot of strict rules in this building about recycling and compost, so keep those separate. I know there's some big garbage cans there. There's some here in the kitchen, and they're all nicely separated. And then,
yeah, and then just for networking, it's if folks are wanting to have chats during the speaker sessions, that's totally fine. We just ask that you go back to the room back there so that you're not having chats in here. It just distracts a little bit from the speakers. All right. One other thing that we wanted to talk about tonight, we just wanted to take a few minutes to talk about something that we're adding, which is a behavioral code of conduct. So as the meetup's grown over the last year and a little bit, we've obviously got a lot of people joining, which is super awesome. And we want to make sure that this continues to be a really safe and fun, informative atmosphere for people to network and learn from each other. So we just want to reiterate like some of our values, that we want to make sure it's a safe, fun, inclusive environment, free of harassment and discrimination and any disrespectful behavior. So we expect that all members who attend will act with respectful and appropriate behavior, and that the people who attend have a valid interest in being here. So I think it's really important. If anyone saw the RSVP list tonight and then the wait list, the wait list was twice as long as the RSVP list. So we just ask that if you're going to attend, that you're here to talk about data, you're here to network with your peers. And if that's not why you're attending, if you're here for free food and drinks, that we ask that you leave those spots open for other people, please. Lastly, most important, if you see or are the victim of inappropriate behavior, please come and report this to one of the organizers immediately. You can do that in person, or if you feel safer, you can do it over email afterwards. So we just want to remind everyone that we're volunteering to do this. We don't get paid to be here. So while we want to have a really fun time, we just want to make sure that everybody's safe and that everyone's enjoying themselves. And this behavioral code of conduct we did add to our meetup. So if you want to go and actually look at more of the details there, it is available there. And our emails are all there as well if you ever need to reach us. Okay, so on to more fun stuff. As always, we do want you to share your feedback. So we'll put this up again at the end of the night, but we do have our survey as always. And we did have, is Ricky Wong here? No, damn it. We haven't had someone here yet as a winner. Anyway, we'll send this to Ricky, but we had, Ricky was our winner from September. And with that, I'm gonna ask Jerry to come up and join us. So give him a round of applause.
Thank you. All right. My name is Jerry Lowe. I'm the Senior Manager of Data Ops at Wave.
I've been here about a year, and it's been really, really exciting. Wave's a great place to work. So the agenda we're going to go through is a brief history of our current data stack, what are our objectives with our modern data stack in terms of modularity and scalability, and building platform services. So I'm going to go back in time and talk about a little bit about when we started. In 2018, we basically, as you can see on the left side, that was our architecture. We used DMS, Python, SQL scripts to load to Redshift. It worked pretty well, and we used Looker as our analytics. But over time, what happened was we added a bunch of new services that evolved with Wave. So, oops, sorry. One of the challenges with the monolith that we built over time was that it really wasn't scalable, and there wasn't really a interoperability. So therefore, it was difficult to add new capabilities to it. So everything was custom built. So with a legacy stack, the focus of the data engineers was really about supporting the infrastructure. The result was longer development lifecycle. One of the biggest challenges we had was unknown tech debt when we were building pipelines and data silos. At Wave, we don't really operate with a platform. So every application had its own database, its own proprietary set of data. So the data engineer's role was really acquiring the domain knowledge quickly in order to assemble and stitch the data together. So we also had a lot of manual operations. So some of the work, the data had to be manually cleaned and then reloaded, which caused other problems. So it was also maintenance intensive. We often had pipelines breaking for no reason, simply because of the tight coupling between our monolith and the application DBs. So with a module, one of the things we really wanted to do with the new stack was really focus on decoupling and scalability. So as you can see, this is really our new stack, which together gives us storage, processing, and ability to analyze data in a scalable, efficient, and cost-effective way. So I'll go through some of the key things we were working through. Decentralized architecture. So we separated our storage from our compute. That was one of the big things. Scalability and flexibility. We run serverless, so that allows us to delegate the responsibility for infrastructure management to the cloud. We do a lot of real-time processing, so that allows us to have insights and inferences in real time, something our batch processing really wasn't capable of doing before. And then also with a shorter development time. Using industry standard tools, we don't have to reinvent the wheel. It's something that we were doing previously. And interoperability, which allows us to share data in a simple, straightforward way. So one of the biggest differences with a platform with us with our modern data stack is that now the engineering team's focus shifts from support to building a scalable architecture. So modularity, that means that the engineers are really looking at tools that will really enable us, and the mix and matching of tools that will allow us to scale our architecture. Serverless, something I mentioned earlier, which is we run serverless so that we don't have to manage the infrastructure. DevOps, so everything we do now is through CI/CD, and we use Terraform for all of our infrastructure. So everything is in code. And cost optimization is another one, which is we use AWS Cost Explorer, and that allows us to manage our costs and look at areas where we can do local optimization to make our services run cheaper and faster. And lastly, the engineers now are really working on hard, challenging problems like scalability, interoperability, and other things like that, which are really fun because you're always working on something new and challenging. Thank you. Any questions? All right. Well, thank you. Sure.
Can you talk more about the serverless piece?
So what happens is on AWS, we run, so our Glue is run on serverless. So therefore we deploy it to the cloud. It auto scales for us. We don't manage any containers, anything like that. The infrastructure is all on the cloud. We don't have to do any gates. So when we, let's say, load history with a large volume, Glue auto scales for us. Same with Kafka.
Is Glue your main orchestration engine?
If you go back here, oops. Glue is really used only within the lake. So it only manages that part. So we have a asset transaction data lake. So that's what we use with Hoodie and Glue. I didn't touch upon this, but the way the data lake works, we could swap out Hoodie and Glue with Hoodie and EMR or Delta Lake. That's the way we designed it. So, but to answer your question, Glue is serverless. It costs more though. But yeah, to run Glue is more expensive than, let's say, EMR, but you don't have to manage the infrastructure. Okay.
Hello. Yeah.
Hello.
I do see here two cloud services, right? One is Redshift, another one is Looker. Why was it that you chose Redshift for the cloud warehouse and Looker for the dashboard? Was there any reason for using two cloud services at the same time?
Well, Looker is really for analytics, right? And Redshift is the analytics database. So they do different things.
Yeah. So, but my question is, why the combination of two cloud services? Is there any reason for that?
Because they serve different purposes. That's the reason.
Thanks.
Does that answer your question?
Yeah, it's yeah. I'm kind. Yeah, it's something new that I've not seen. That's why.
Pardon me?
I've never seen two cloud services in a architecture. Something new, but yeah.
I mean, we could have used, instead of Redshift, we could have used Snowflake,
Yeah.
right? But then that would be still two cloud services, right? And if we use Tableau instead of Looker, it'd still be two.
Thank you.
I was just curious about the kind of volume of data within your data lake and how you think about, I guess, the trade-off between maintaining the data lake versus using the storage optimization in Redshift and kind of using like the hot data layer in Redshift, or is your data lake totally cold data, or how do you manage that?
The S3 is still, you would say, hot because you can retrieve it. We didn't put it in Glacier, but S3 storage is much cheaper than Redshift. So that's why as you get bigger, we're not that large, so we can get away with a Redshift. But if we were like 20 terabytes or something like that, Redshift gets pretty expensive. So then we probably evolve removing Redshift to use Presto or something like that. But Redshift suits our needs for now.
Got it. So are you using sorry to go too deep,
No.
are you using in Redshift, the nodes that you're using, are they like the DS2s where you're combining the compute and storage, or is it the more like, I think they came out last year or 2 years ago where they bifurcated storage and
Yeah,
compute?
we're using RA3s.
Okay.
That's what we're using to separate storage from compute.
Gotcha. Okay, thanks.
Great question.
So the previous question kind of touched on it, but I think I heard Kafka mentioned. I'm wondering if you could talk about not just like Kafka, but any sort of streaming solutions you provide and like the total volume of data there. And are those also like serverless, like autoscale, or like you have a certain number of pods? How does that work?
So our use of Kafka is a little bit non-conventional. It's not like how an IoT is. We have a lot of connectors, but the volume isn't really high. But not sure if I answer your question, but in terms of Kafka, we use the serverless Kafka, MSK serverless.
Okay, could you be more specific on like how many like nodes you would have for your Kafka server, or like EC2 instances if you're hosting on
I
that?
have about 36 nodes.
Okay.
But the volume isn't really high. And we had considered using, let's say, Confluence Kafka, but the cost would have been just through the roof, just because our use case doesn't really line up.
Cool. Thank you so much.
You're welcome.
Thank you. How did you make a decision to go serverless in contrast to use your own infrastructure to manage the deployments? And did you do any calculations on the costs of the two?
So cost was less of an issue for us because the size of the team is quite small. And if you burden the team a small team with infrastructure management, it becomes harder. So that was the reason we decided on serverless. It doesn't mean that in the future, for example, we may opt to run MSK on a cluster and then manage that ourselves. But it was also easier to get us up to speed quicker.
Anyone else questions? Oh, we got a couple. Also go here and then I'll head over there.
Hi, I was curious about, so two questions. When it comes to Looker and Redshift, can you speak a little bit about the difference maybe in data models, managing data models across both the cloud services and how that is? And I'm also curious as to how managing data quality has evolved between switching between the two models.
So one of the things we have to evolve with the way we do Looker is that we're going to try to push all that responsibility down to the models on the Redshift side, so that we're actually looking to build tooling to automatically populate LookML from Redshift. And the only way we can really do that is to not have them different. Does that make sense?
Just curious because I've used Looker before as well. Did you end up using Delta tables in Looker? I'm just curious.
So I'm not the best Looker expert, but we don't use Looker much other than the LookMLs, and we might have some derived tables. So we haven't really, we've only scratched the surface of Looker.
Yeah.
But when we look at it from the stacks perspective, what we want to do is really dumb down Looker more, so that you're really just doing the presentation part. And all of the logic is now pushed down into Redshift. Again, if we sync it up, then that would allow the metadata to be pulled out. And then through a tool such as Secoda, we can expose all of that. So it also allows us to turn around things faster, because the more hops you have, the longer it takes.
That makes sense. And how did data quality involve, or managing data quality?
So what happens for us, data quality, everything is exposed through Glue and the data catalog. What our goal is, once we have everything set up, because we're still halfway through our stacks build, we want to actually use tools such as Monte Carlo, or Secoda has it, or any other tool that does observability, and then plug that in, and then have that solely responsible for data quality. But one of the things we've done on the Glue side is we do no transformations. We just push all of the data through, and we have Hoodie doing the CDC part, and we delegate all the responsibility for modeling and those things to the analytics component. So you can see it's actually totally decoupled from the rest of the stack. And then just want to add that one of the things that Diana will talk about is just how that architecture works.
Thank you.
There's a question over here. Yeah. I'll sneak in here, sorry.
So recently, the Terraform moved from public license to business license. So is it somehow affecting your cost, or you are thinking about to switch to another platform for the Terraform?
Can you repeat the question?
The Terraform
Yes.
from the HashiCorp, they are switching their license from
That's
public
right.
to business. So are you planning to switch to another platform, or if you stay in Terraform, how it might be affect the cost of the operation?
That's a great question. That's probably more of a question for our DevOps team, since Terraform is the standard that we've been asked to use across the board. So I think when that comes with Terraform's licensing model, I think it's something we have to revisit across the board, because we're pretty embedded in terms of using Terraform. But that's a great question.
All right, maybe we'll take one more question. Yeah.
I'm not really sure if I missed it or not. You said the Redshift is more expensive, and there's a cheaper option, but why are you still using it?
Can you repeat the question? You said
the
Redshift was more
Redshift is
expensive?
expensive, right? For you? Did you say it was more expensive?
Yes.
But you're still using it, even though you have a cheaper option? Is there any reason?
Redshift is a more expensive option, it is, but our scale makes Redshift the right choice for us today. When the volumes become very, very large, then Redshift really doesn't become the best approach. But for us, the scale now is fine. So everything is kind of like when you get too big, you got to look at something else.
Thanks, everybody. We'll kick it off to you, Diana, now. Thanks. Let's give Jerry a round of applause. Thanks.
Hi, everyone. How are you doing? Good. That was a great session. The questions was also awesome. I actually didn't know you guys have so great questions. But mine will be a little bit different, or we're just moving forward. We just discussed what's happening, or Jerry told us what's happening between the lot of focus was on the glue jobs and those where we don't really have transformation. Now we have those transformation. Couple of words about myself. So I've been in analytics, process analytics, business analytics for 10 years or something like that, 6 years, and ETL developer, data modeling, database modeling, or whatever in data engineering. I've been a data architect, various roles, and now I'm here. And I had a privilege to be exposed to various options of what happens in data domain, but specifically with a focus on analytics, which means learn something from the data as what we have, get some knowledge of that, get some understanding. Let me know, do we have any data analysts in the room? Yay, yay. Lots of love. I know you struggle. What I'm going to talk about today, first of all, we know there's people with a different background in the area, in the audience today. So for some of you, when I say data transformation, that means a lot to you. But for the others, it doesn't really say much. So we just wanted to make sure we're really on the same page when we say data transformation and what the story I'm going to tell you. Once we're done with that, I want to tell you how our data transformation layer used to look like. And probably you will tell me why we didn't like that, but I will also tell you why we didn't like it, the way it was. And then I will tell you how we designed this layer now and why we think they're gonna work better. I like to explain, so we start with the data transformation concept, and I like explaining concept with the real business examples. Instead of saying, oh, this is a tool, like some SQL, some Airflow, whatever. No, let's look at the business problem, because that's why we apply those tooling, to deal with some real business problems rather than due to the beauty of the tooling itself. So imagine the business comes to us or came to the analyst and asking, you know, a new market player really been aggressive recently. They launched some campaign, they've been spending lots of money. Do you think we need to start worrying about our high value customers? Because we obviously don't want to lose them. Is there something happening? Oh, we're good. How you would answer this question? It's a question to analysts, but pretty much anyone can give me ideas what you would be looking at to answer this question. Shout out. Yes, something else? What's model? Yes. Good. Something else? Visits, customer lifetime value model, or essentially the LTV dynamics, whatever you call it. Transactions, history, pretty much anything of the activity. And then the question, where are we going to get this information from? What we typically have on our data sources. So we may have a data source, an application, which means authentication. So imagine we have like several services or several business applications, and then there's one authentication management. So we use user credential and payment details here. It may be structured as a table, but it's maybe key value, it's maybe anything. Then website activities or application where we store sessions. They like tables or any object as events. They typically have event ID, the timestamp when event happened, and then this notorious line of details. It's very great for engineers, but as analysts, we really don't like digging into those details because it can be anything without them. We cannot really analyze it right away to answer, does our sessions of high value customers are dropping or not? We also, okay, the session may be dropping, maybe not dropping, but transaction not dropping. That may mean that people come window shopping, that they go out. Like there could be a bunch of information. It's also hard to find answer in one search. And of course, production database, where we have transaction assets, amount of transaction, all of that stuff. But that's not what we want as data analysts. What we want is actually well-integrated information, ideally one flat table or a data mart, where we have a user ID and all the information associated with that lifetime value, average sold product, maybe not the date when the user was registered, but rather a cohort of time where I associated with user risk. Similar with the segment. I'm not really interested in how much they spent the last time, but I'm interested, are they still in high value cohort? Or they recently moved, they degraded their segments, so on and so forth. So how we get from those dispersed and like quite granular, not integrated information back to the valuable data assets enriched with the attributes which speaks a lot to business, how we do that? This is what we call data transformation. This magic has a couple of components. First is transformation script. Typically, this is SQL statements, but not necessarily, not limited to. It could be Python, it could be R, whatever you use to transform your data, to enrich it, to flatten, to integrate it together. And we also need orchestration. Orchestration makes sure the transformation script right at right time, with right frequency, and with respect of the dependencies of one another. So this is how we get magic, and this is what analytics engineers are doing. We are making magic. So that being said, how our data transformation layer used to look. As Jerry already explained in this part, so there has been glue jobs, but there is no transformation. It's being copied one-to-one with like minor adjustments. And this is where the new data is being created or is being flattened or integrated. All the transformation, like all the orchestration was made by Lambda functions. And each Lambda function has dependencies to respect. All the Lambda functions being executed sequentially, and there is pretty much every of them looks at 20, 15, whatever other functions to be completed successfully. And then they've been completed. Within each Lambda function, there is a series of SQL statements being executed, starting with insert select, and then update statement or select of update, enriching one final table, which is typically a dimensional table. Some of them take in source field directly from the source. The others generate a new field by the particular business rule. So all together, after all those statements being executed, we get the final table. It can break at some point, may not, but it's not really straightforward how a particular and when a particular operation is broken or not. And it's quite not trivial task when you have to deal with sorting a particular incident. We didn't really like that. You may tell me why, but I can tell you essentially. So it's not scalable. The framework doesn't have exact rule how you would add a new pipeline, a new data asset. You need to investigate each time where your particular update statement has to land. It's a bit easier with updates, but it's also hard to, for example, apply a business rule or change a particular business rule. Or none of the pipelines are like the other. You need to investigate it each time. It's not really efficient in terms of compute because update statements are quite expensive. It's obviously not decoupled. The business logic and source data come all together, and we don't really have boundaries between no business rules applies and then business rules being applied. Yeah, it's not extensible also in terms of the framework is homemade. We leverage Lambda function, yeah, but we don't really can leverage various features that's becoming available with open source solution, releasing new versions. So the framework is not really designed for lots of integration or various scenarios of application. And it's not really good for near real time or faster updates. It works only when you deal with nightful refresh, which we wanted to discontinue and get updates more often. Not exactly real time, but like on a more frequent than once a day. And it's not welcoming for business users, not welcoming for self-service. In fact, it's not really straightforward how you would be able to create your pipeline if you would love to do so. So you've seen this picture already. Just wanted to highlight what we've been changing. First of all, we manage dependencies and register dependencies between the models or the tables to be created, not through Lambda function, but through DBT. The second change is we rethink our modeling. That's probably the biggest change. So we add decoupling here. First of all, the source data, after being delivered by Gloob with no transformation, gets really decoupled and written into highly granular data vault. From data vault, we're able to assess the dimensional models. No business rules applied here. The business rules being applied on the third layer, which means if our understanding of a particular value, I mean a particular metric, like we've been thinking about LTVs like 60 months and now we think that 72 months or whatever else. Changing, we need to make changes only downstream. All the upstream stays unaffected. In fact, since it's being highly granular, we can reuse, and we aim to reuse, a lot of assets which have been written only once here to data vault as many times as we like through dimensional and through business smarts. This is the second biggest change. And the third one is transformation controls or observability, which means observability tool and data observability, metadata management to make sure, first of all, we are able to detect incidents as soon as possible, as fast as possible. And the third, we making all the description of business assets. That's the first thing. But at the end of the day, all of the data assets, what we have, we're making them exposed to business users to unblock them and block self-service to make them feel comfortable using data at any user application, user interfaces available to them. Whatever is Looker, whatever is Jupyter, this is probably the two most common, but maybe querying them directly as well. That's kind of it. Any questions?
Okay, see one back here.
Hello. So how do you handle data governance? Is there any tool that you use to handle data governance?
That depends on which aspect of data governance do you mean. But I would say there is a combination of both. Here we're still looking at various options. That's why there is no particular tooling being added, but definitely there will be some.
Okay.
Still running proof of concepts and proof of values.
Hi, Diana. Great presentation.
Thank you.
I had a question about self-serve. I know it's a pretty popular term these days, and I used to work in a company where I guess self-serve is a big thing, but I also kind of want to understand, like, on the ground, what's the experience like to actually get business users to look at the data and figure out what to do after that?
That's a great question. That really depends on what you have available to you, which means what a data culture currently in your organization. If it looks like, oh, we just like our dashboards being really assembled for us, nothing else, then you need to start from, I don't know, from the very beginning maybe, and just whatever you may leverage to make them interested and show this is the safe place. What could be an example? Just one explorer in the Looker, if we're speaking about Looker, and ask them questions. I've been doing that in a previous role. It was also a part of onboarding for some business users. You need to find out what was our revenue that year, that month, and that country, so on and so forth. So they start playing around. When they essentially see that this is easy, this doesn't break anything. For example, it's very common when people start playing with Explorer, they, oh my God, I broke the whole looker in our organization, not gonna work anymore. Then they start understanding, okay, I actually have my question. And before, to solve that, I needed to create a ticket, reach through Slack, wait 2 weeks, but now I can do it myself. But then they start become more demanding to you as a provider. So that really depends on your situation. But what is it? Just make a safe place to play around and give some prompts so they start answering. So then they will start asking their questions and put their demands, which will mean explicit cataloging, well reusable data assets, increased literacy, so on and so forth. But they need to have this need first. If I answer this question. This maybe could be a book about that, I think. But it's an awesome question.
I'm curious if there's any kind of testing you use within your transformation pipelines, maybe unit testing or I'm aware about DBT tests, but unit testing is specifically what I'm curious about.
Mostly that's, we're just deploying, just building those pieces of architectures, not fully assembled. For now, it's going to be DBT tests, generic tests, and custom tests. Mostly that's it. When it comes to deployment, but that's completely different thing, the CI pipeline, those two major things.
Any other questions back here? Okay, I'll make the rounds.
Hi, thanks for the presentation. My question is, this is effectively a pipeline. If there's any delays in the pipeline, how do you handle like late data backfilling? Do you have self-healing processes? Maybe can you talk a little bit about that?
I know what you're asking. It's a little bit painful to assemble all of that stuff. So with the existing architecture, with as is, there is no such thing. Full refresh. What is available, that's being propagated. We'll check it the next night. For this architecture, this pretty much the similar field when you populate in the DBT. So you don't have this later parking table, less arrivals, so on and so forth. We don't have this problem again, and but probably due to the specifics of the layout of the architecture of the like how everything works essentially. So we don't have this issue now in the existing design, and we don't foresee we're going to have a lot of them in the future. There will also everything runs in a data wall in parallel, which means whatever showed up, we see there has been an update, we're triggering pipelines as being written, but we don't really trying to. We're not dealing with not full line where when the part of it's already arrived, the part of the attributes, and the last is not arrived. So you have like null or something, you need to mark those incomplete rows. We don't really have that because here, for example, I don't know if you're familiar with the data vault design or not, but you store just IDs of the entity and you store attributes on the other table. So you don't have these incomplete rows, essentially.
Hey, I don't have a question, just a plug around unit testing. We're building it in DBT and now actively, me every day. It's going to be out in 1.8. So if you want to talk about unit testing, please come find me.
Yes,
cool, thanks.
Very excited for that.
I think you mentioned about in terms of the transformation only happen on the third layers, right? So you will keep the raw data integrity as much intact as possible. So my question is, what if during this kind of business application layers, the business user discovered a new kind of metrics, and then is any a process kind of re-inherit those metrics back to the kind of a centralized management?
Mm-hmm. Yeah. We try to keep that abstract just to have this, I could say, purity or isolation between rules applied and there's raw data where those rules being applied. The integrity, if you're speaking about the design or the definition of object is not being kept, it stops somewhere here, and this is the model is different. What the thing is, that's nothing derived, no derived attributes is being created before you get here. If you're asking about write back, which means the storage, because at some point, for example, the value of LTV is also an attribute of either business or user. It's right back here in the business smarts. So you may imagine this, it keeps the same structure here plus a couple of tables. It also allows you to play around, for example, with materialization strategies, because you can have them as views, not materialized. It's like not being heavily used and materialized, other than being queried by pretty much everyone in your organization, but you can recalculate them really easily. But for now, we don't think we're going to write back into Data Vault, despite this kind of the approach they think that's possible practice to write back in a store, but we want to enrich, not really enrich, just to restructure and then only enrich here and write back only to the business storage.
Makes sense. Thank you.
All right, maybe we'll take one more if there's another question. Oh, we're at the front.
Hey, so it looks like you use events a lot for your analytics and reporting. So is your team like involved with the event instrumentation within the application itself?
Which application do you mean?
Like, so the events that like you're using Kafka and CDC to generate events, and it looked like you're using a lot of those event tables within your data modeling. So
no, I just used this example.
Oh, I see. Oh, for like, okay, I saw the curly brackets and I thought you were.
I've just saw them so many times because as analyst, I've been, could you please answer our question? And this is what we got.
I see.
I know how they look at, but if you want to speak about how we send events from Kafka, this is Jerry. He's the best person to talk about that. How it's really like structured, the topics, for example, or.
Sure. Does your team like, work at all with product folks or engineers to like make sure that the events are capturing everything that you want, or that the right things are being logged,
Mm-hmm. Here in this, what we are currently building and what models we have in the pipeline, there is no really events being really involved. I think I kind of from experience, I know what you mean, but we just didn't encounter that problem. For now, we're dealing with what's already been recorded, already been more or less understood and described. We're just finding the better structure and the better orchestration for existing stuff. We will get to discuss and how to structure their events later. We'll get to explaining them why that didn't work. That will be another Meetup presentation for sure. And if you're speaking about how we're dealing with tooling, where we contribute and dealing with actually dealing with some DBT packages, we're building a specific DBT package to run the data vault. That probably will be another Meetup presentation.
Nice, awesome. Let's give Diana a round of applause. That was awesome. Thank you. All right.
Thanks for great questions.
Yeah. So how are people feeling energy-wise? Do we want to take a quick break or do we want to just power through? Power through? Okay, let's do it. Well, in a turn of events, it's going to be me. All right, so let's do this. I'll try to go through this quick and we can get back to the networking. So I'm Lindsay. I'm sure I've had a chance to meet a few of you here, but if I haven't had a chance to meet you yet, I'm the head of data at Secoda. I also teach a course on advanced DBT with UpLimit. I've been working in the data industry for about 12 years now, and I've launched a data team at BenchSci, and I led the data team at Maple previous to joining Secoda. So yeah, if we haven't had a chance to meet, let's come say hi or feel free to add me to LinkedIn. What is Secoda? Who has heard of Secoda here? Can you put your hands up? Oh, wow. Okay. Wow, look at that. That's awesome. We got a bunch of the team members up here in the front, so that's awesome. So what is Secoda? Secoda stands for Searchable Company Data, and we offer data teams and data consumers the ability to search through their entire data stack and metadata as well. So you're able to look at things like cataloging, search to find certain assets, and then even see column level lineage through your whole tech stack. And we just recently added monitoring. So that was something that Jerry mentioned, but we're very excited. We just added observability for data and also metadata, which is very exciting. So we're actually going to talk about metadata today, which is going to be cost. So let's dive into it. So data teams, we spend a lot of our time measuring the performance of other people and helping to optimize their performance. but we're not actually very good at doing this for ourselves. If you look at how data teams kind of optimize their performance, we don't really do it in a very data-driven way. And if you ask us to measure our value, our ROI, it's really hard. Who has been asked to measure the ROI of their data team before? Were you able to do it like in a day? Did it take a little while to figure it out? It's not that easy. And we get a little hairy when you ask us to do it, because it's like, obviously we're delivering value. Why would you question us? And if you Google this on the internet, you'll get 28 million results on how to measure the ROI of your team. And if you look through a few of them, they're all kind of giving you different stories. It's very difficult. Some people even question, should we even measure the value of a data team? Should we just make other people do it for us, like the people that you are delivering the value to? And Tristan, from the CEO of DBT, had a good article here from April 2022. He said, we tend to have very hand-wavy conversations about the ROI of data teams. And I know that I've made this a hand-wavy conversation before. And he makes the argument that no organization is really doing this perfectly. And like, it's just really hard, so don't make us do it. We've got a million other things to do. Our backlog probably looks like this. And this was okay. When the economy looked like this, it was fine for us to wriggle our way out of this question because people just believed in what we were doing, right? Things don't look like that anymore. So things have taken a bit of a turn. The economy has been hit pretty hard. We're seeing layoffs across a lot of tech organizations especially. But businesses are more focused than they were on short-term profitability than they have been in the recent past. And so while a lot of businesses might have been excited before to just kind of throw money into data and kind of jump on the bandwagon of having the sexiest team, they're not really excited about doing that anymore. They're coming now and saying, what exactly do you do here? What's the value that you're delivering? Your team has really big salaries. You're spending a lot of money. What are we getting out of it? And so unfortunately, data teams are getting labeled as cost centers instead of value drivers. And unfortunately, those are sometimes the first teams to go when business gets tough. So what do we do about this? Here is a very, very simple ROI formula. I'm not going to stand up here and pretend that this is complicated, but if we want to think about what the ROI of a data team is, you can break it down into how much value are you delivering to the business and how much does it cost you to run. So if we want to increase the ROI, we can do that in two ways. We can increase our value, which we've already talked about. It's hard to measure this, or you can decrease or maintain your cost. If we talk about increasing value, there's lots of different ways to do this, but bringing your data team closer to direct business impact. So if you can figure out a way to monetize data, if you can improve the usefulness or the accuracy of your data, or improve the adoption and the usage of the data that you have at your company, you're going to be increasing value. But unfortunately, to do all of these things, you probably have to have an advanced data stack. You have to have a lot of data. You have to have production level quality. So that costs money. So let's talk instead about reducing costs. Well, you can increase the impact of the team that you have. So you can try to get your people to do more with less, which nobody really likes doing. You can look at optimizing the data infrastructure and operating costs that you have. So either try to bring those down or try to control them as you're scaling. And then you can think about reducing, eliminating, or bundling tooling costs. And with all the tools that exist out here today, this is what the landscape looks like in 2023. There's a lot of overlap, right? There's a lot of things and tools that do the same things. And the other problem is that a lot of these tools are abstracting away the complexity of what's going on under the hood. So it's making it easier for more people to join the conversation and more people to be able to enter the analytics field. But it means that maybe those folks aren't as technical and they don't actually understand what's going on under the hood. And that can make it really easy to spend money. So just to put some numbers to this, don't maybe look at the absolute numbers. I got this from a blog post, so I don't know where this person got these numbers. But if we just want to estimate the scale of how this can change from year 1 to year 3, if you're starting a data team in year 1, your costs may look something like this, depending on the size of your data and how many people you've hired. And within 3 years, you can start to see scale from year 1 to year 3, that it could triple in some cases, just alone on tools. And then when you add the personnel costs, you think about, you grow your data team from 1 to 10 people, your salaries are going to look like this. So what the heck is going on here, and how do we get control out of this? How are data teams falling into this trap? Well, I'm going to borrow from our friend at Mother Duck. And this was a really good presentation that was at Data Council this year. So if you have time to go watch it, I really encourage you to take a look. But basically, he summed it up here that ballooning costs are really a lot of data teams kick the can down the road in the sense that it's really easy to get started with some of these cloud tools. And then it might not cost you much on day 1, but you push that cost out 2 or 3 years and things really start to get expensive. A couple other things he called out, ELT is a big one. So moving data into your data warehouse can get very expensive depending on how big your data sets are. A linear increase in data, if you're doing really, cross joins or anything like that fancy, that's going to increase to an exponential cost potentially. Self-serve analytics, if people are hitting and querying your data a lot, that can turn into really expensive output. DBT, not to shit on DBT, I know we got some DBT people here, but it tends to bias to actual new asset creation instead of removing things, and I think that's the case for a lot of these tools out there. And then lastly, I think this is the one that I want to focus on the most, is that costs are not exposed. So it's not super easy to go in and see how much money am I actually spending until, maybe it goes to some finance person and they come and yell at you as a data person. So add to this is that a lot of tools are also moving to consumption-based pricing, and now you're getting charged consumption for every single step in your workflow. And so what that creates is the snowball effect where you start to get more data, you get more feature requests, everybody wants more of your data team, and it just starts to kind of compound over time. So the problem is that the relationship between cost and time at best probably looks linear, which is still not very good. And at worst, it probably looks more like this. So we need to figure out how do we get control over this and start to change the relationship. And even if your costs are scaling linearly, you have to be scaling your value at the same time. Otherwise, your ROI, you're just undercutting the value they're delivering constantly. So you can't manage what you can't measure. So I think that data teams need to be focused more on measuring the costs and thinking about how you can optimize that as you scale. So if we think about breaking this down into the data engineering lifecycle, we can look at the entire chart, and I'll give kudos to Joe Reese and Matt Housley. If you haven't had a chance to read the book, The Fundamentals of Data Engineering, I really recommend it. It's a very good book. But in this, they come back to this diagram several times throughout the book where they kind of take you through the journey of the life cycle of data. And if you were to overlay the modern data stack, it looks pretty much the same. So we have obviously data sources on the left, data moves basically to the right, and then that's where it gets served for end user purposes. And when we start to look at some of the tools that are here, if you're going and building a whole cloud-based modern data stack, you can start to look at some of the pricing models that exist in these various tools. And thinking about how you break this down, data tooling can typically be broken into 2 categories. One would be static, so things that aren't going to surprise you from month to month. That might be annual contracts, receipt-based pricing. I have salaries here. Hopefully your salaries don't stay static for too long, but they're probably not going to change like from month to month too often. And then the variable side of things, which is where things get kind of scary. So with ELT, you can get, I've been in a situation where we had an engineering team change a bunch of historical data in Jira, and it updated like thousands and thousands of rows, and we had a really scary 5-tran bill the next month. So that was like totally out of our control. We didn't know that was going to happen. And that can definitely be something that happens to your data team. The warehouse obviously is where the majority of our cost is probably going to be. So compute costs are hitting basically in every step of the way. Transformation and orchestration, and then obviously if you're adding more data people to your team. So if we want to actually go in and figure out where the cost is incurred in each of these tools, we would go into a dashboard looks something like this, maybe in 5-tran, and we could see, cool, this is how much money I spent in October. Super actionable, right? So then maybe we want to dig into it a little bit further. We can go back and to see specific days, and maybe I can look at specifically which tables drove spikes in cost. But there's really not too much you can do beyond that other than just figure out, which things are maybe loading more rows than I thought. You don't really have a lot of control necessarily over what's going to get loaded through 5-tran. And then if we want to flip over to something like Airbyte, they do a bit of a different pricing model. Sorry, actually, go back to this for a second. 5-tran's pricing model is based on monthly active rows. And so they charge you based on how many rows are being loaded. I think there's something to do with whether or not it was active in the month. So they try to help reduce the cost, but in all honesty, it's pretty expensive. And then Airbyte, on the other hand, they do credit-based. So they instead look at different types of assets that you're syncing, and they charge you differently based on that. So that in some ways can save you a little bit of money. And also you can tell it how many credits you're going to allow it to have. And if it spends through them all, it's just going to turn off, which can be helpful sometimes. And then there's Snowflake. So Snowflake has dashboards that look like this. You can look at compute and storage costs over time, and then you can break it down into particular warehouses. So if you set your warehouses up by loading, monitoring, reporting, or transforming, and you only give access to the certain tools in your tech stack to those warehouses, you can keep track of which tools are driving up costs. And then let's throw Looker in there just for posterity, but Looker doesn't actually show you, how much you're spending on Looker. Looker would be an annual seat license, but you'd be able to go in and see, how many of my users are querying things, how often are they looking at things, who are my power users, that kind of stuff. So what's the problem here? Like, we've gone and we've looked at all of this data, but if I want to generate information or make decisions, what's the problem? It's all siloed, right? Everything's siloed. Access to the tools is often limited unless you're an admin and you have to have billing access. And it's really difficult to generate insights. So if there's things that are related issues across all these tools, it's pretty hard to actually generate or figure out what's going on. And hey, doesn't that problem sound kind of familiar to data teams? Isn't that the exact problem that we solve? So here's what I propose data teams start thinking about doing is figuring out a way to build an operating cost dashboard for yourself. Obviously, this is going to totally depend on the tools that you have in your tech stack and the availability of that cost data or other information to pull out. But some ways that I've thought about doing this is with Fivetran, they will pay you, or they will let you pay them to figure out how much you're paying them. It's like very meta. But they have a Fivetran log connector, so you can get that data out and look at specific, basically the data that we saw in that other granular dashboard that they had with a little bit more information. There's some individuals here based in Toronto called Select. So Ian and Niall have built a really interesting DBT Snowflake monitoring package. So this lets you look at down to specific queries, like who is running this and how much is it costing me? So you could then sum that information back up. You could tie that back to specific teams. You could look at particular people. And if you give a different user account for every single purpose that you have for Snowflake, you can get super granular with this. For transformation, if you're looking at, which of my DBT pipelines are running more slowly than they were before, and maybe that's causing compute to rise, you can look at the DBT artifacts package, or there's a company called Elementary that has some information around this. And then if you really want to get to include everything, you could even track, your static costs could be in spreadsheets or seed files. So if you go ahead and build something like this, this is something that I built from a Snowflake monitoring package. So this is just looking at Snowflake, but this allows me to go in and say, how am I seeing these spikes and what warehouse was that from? Or where am I spending the most in terms of my databases? Who are the particular users? Sometimes it's me, but who are the particular users that are spending the most money? And then you can actually go in and get really granular on that side. But wait, so cost is a lag measure. So what's the problem with that? Yeah, there's no warning, right? It's like it's already happened. You've already spent the money. So how are you supposed to proactively do anything about this? So I think impacting costs directly can be challenging. So also adding lead measures by using metadata, adding that into your dashboard or looking at these things. We already talked a bit about the DBT artifacts package. But looking at the number of queries that you're running, how many rows you're loading, how many times you're syncing your ETL tools, maybe you can change that. Asset volumes or people in your BI tools just building more models, more tests, more dashboards. Individual query performance. Do you have a particular model or a model neck in your pipeline that's really slowing everything down? Maybe you can improve your CI runs or your DBT refresh schedule to look at making that run a bit more performant. And then lastly, failure rates. Like if your pipelines are failing, you're probably going to have to go and reload that information again to get everything fresh. So the more your failure rates are going up, that can lead to costs as well. All right, so let's bring this home. How can we think about optimizing costs? So the big takeaway here is probably just do less. So with generation, be strategic about the data that you collect. So Jonathan had a good question about what events you're collecting at Wave. A pattern that I've noticed is a lot of times at early stage startups, the first people to put the events in are typically the engineers, and they just want to collect everything. So they'll go in and put like API calls and auth calls and things that aren't really useful to the business necessarily. And then us poor data people have to ingest a 40 million row table out of Mixpanel that maybe has just a bit of useful information. So thinking about your data collection strategy and how much data you're collecting and making sure that's something you're actually going to use for the business. Otherwise, you're just moving data around that isn't really valuable. Ingestion, this is a big one I've learned the hard way a few times now. So you can ingest less data, make sure that you understand the syncing strategy and how historical data rows get updated. Watch out for databases. If you have a really big database, a really big table, sorry, and you're not really sure how historical rows get updated, you might get a sneaky bill from Fivetran. And then credit-based tools. A bit of a hack here is that you can just figure out, how much am I willing to spend in a month on a credit-based tool and just only give that amount. And if something goes awry, then you're able to actually go in and make a change before it spends without check. On the transformation side, run less models. There's a trend here. Figure out different modeling approaches. So, the activity schema is getting talked about a lot and reducing the number of tables. Query optimization, make sure that people on your team who are writing the queries know how to optimize them and make sure that they're performant. And then using things like Slim CI if you're using DBT, which is just only running tests and changes on the models that you've changed. And then source freshness, so only running downstream refreshes on models that have fresh data in the source. And then the last piece obviously is serving. So, limiting BI access, like don't give, end users who don't know how to write SQL access to really wide raw data tables. Figure out a caching policy. So, tools like Looker will reload the same data or try to see if it already has that data in cache. And then just make sure you're deprecating unused assets. So in some cases that may not bill you directly, but it's good to just get rid of things that are either redundant or people aren't using, because it could end up incurring costs in different ways. And if all else fails, if you're really up against the wall in terms of spending money, go check out this talk from Pedram Navid. He first gave this at MDS Fest, which was a virtual conference that I helped run earlier this year. And he does a great job of walking through in about 30 minutes. I think it's actually, he re-recorded it, this one's 16 minutes. He builds a whole open source data stack in about 16 minutes. So it's very impressive. So obviously it's still gonna cost you a bit, but if you're really on a tight budget, might be a way to go. Okay, so let's bring this home. I think I've been talking for longer than I intended. To optimize tools, always be skeptical up front and understand your scaling costs. So just because when you set up Snowflake or BigQuery, you're spending like pennies at a time, that will increase over time. So be sure that you understand how that's going to increase and what that's going to look like 2 or 3 years down the road. This was one that I learned when I was at Maple, but negotiating contract terms to reduce costs. So if there's something that you're going to use over the next 2 to 3 years, sometimes you might be able to negotiate purchasing things up front. Some like AWS nodes, for example, you can get discounts up to like 40 or 60%, which is really big. Set cost safeguards where possible. So in tools, I don't mean to, again, I don't mean to shit on a tool here, but Fivetran, there's no safeguards built into the tool. So if you give it a credit card, it will just keep spending as long as the credit card is able to take that. So if you can either go with a credit-based tool or give it, a float card that has a certain limit per month, you can kind of build in a safeguard there. And then avoiding tool lock-ins or at least weighing migration efforts. So, if you're putting all into something like Looker and you're building all of your transformation layer in that tool, and then they go and increase the price or something like that, you're kind of locked into that tool. So figuring out ways that, you don't get too far down the road and figuring out if you do have to migrate, what's that going to cost your team in terms of resources. The next one is optimizing processes. So thinking about, if you can, building a cost monitoring dashboard and setting up alerting, setting up targets and projections. So how much do I want to spend in a month? Your finance team is going to be really happy about this if you can do that. This is probably the biggest takeaway, is sharing accountability with producers and consumers. So if there are people who are spending money and compute in your warehouse, make that visible to them, share that with their teams, and talk about it with your data team. So on the data teams that I've worked with, we didn't really talk about cost at all. And I think that's a mistake. I think that everybody needs to take accountability for it and be aware of what it costs to run a tech stack. And then lastly, this is one that I'd love to see more data vendors building tools like this, but building cost optimization into your workflows. So we do data diffing, and we do code diffing, and tools like Datafold do data diffing. We should be able to do cost diff. Like when you have a PR up and someone's reviewing it, you should be able to see, what is the cost going to change if I make this change. And then lastly, the hardest part is probably optimizing humans. So like I said, normalize talking about cost with your teams, drive accountability, and make sure that people know, like, if I hit select star on this table, it's probably going to cost a lot. Maybe I shouldn't do that. Educate your team on cost containment best practices. So make sure that folks who are writing queries know how to optimize queries and that they understand things like ETL loading behavior so that, if somebody's going to go in Jira and change a bunch of historical data, maybe they give you a heads up. And then, as I said here, educating data consumers and producers on, how we get charged as data teams, and then limiting access to prevent mistakes. All right, so let's wrap it up. So investing in cost measurement and monitoring, I think, is something that more data teams should be thinking about. Building cost containment feedback loops, either us figuring out how to do that for ourselves, or we have data teams or data vendors build that for us. And then lastly, drive accountability for cost containment. So that's it. Thank you very much. And there's a note there. If anyone wants to add me to LinkedIn, let's chat.
Thank you for the wonderful presentation. Really appreciate the context and the problem statement and the solutions. Did you find any elegant gatekeeping solutions to prevent scaling problem happened before, like kind of preventative measure to cap the, for example, before the query running for too long or taking too much resources?
Yeah, so this is definitely, there's ways obviously to build into, I know you can set like query runtime parameters and different tools like Snowflake lets you do that. So there's definitely ways to kind of set that up. I think the ones that I am the most concerned about are the ELT tools that just will spend like, it's happened to me more than once. So I think figuring out like ways to build safeguards in that. A lot of tools don't have that built in because they want to spend your money. So I think figuring out ways to build that for yourself. Yeah. Does that answer your question? Yeah.
So there's no like the best tools in the market at the moment. We kind of need to figure it out.
Not unless I know there are some that are working on cost containment. So Select is working on cost containment for Snowflake specifically. And there's a few others, the names are slipping my mind right now, but I don't know of one that like looks at the entire stack and sort of brings all that data together. So you kind of have to build it yourself right now.
Yeah, thank you for bringing that to our awareness because it is one of the most common problems that we run into, and my credit card just got charged like without me knowing.
Yeah. I love the little alert. You get like an email and it's like, you've hit your $200 limit. And then you go in and it's like thousands of dollars have been spent. It's like, cool. Glad you sent me that email.
Hey, Lindsay, great talk.
Thank you.
So I have some experience building a data warehouse to consolidate all the spend data. And something new I learned today was there's a FinOps group where they launched something called like the open source spec for billing. So one of the things that I've seen in the talk was Google, Amazon, they're all trying to align on one standard. So I think going forward, I would expect a lot of vendors would probably do the same as well.
That's great. That's great to hear. Yeah, I feel like I would like to see vendors take a bit more responsibility in that sense of like allowing us to be have more control over the spend.
Yep. And sorry, so one more thing to add to that as well is in terms of like experience, how do you kind of like communicate to your team on how do you kind of like get some of these tools like Airbyte, or how do you pitch it to basically get the funding to start?
Yeah, that's a great question. Luckily, I work at a data company right now, so we're very excited to like try new tools and try new things. But in previous companies, it's definitely important, right? Because it goes back to that value ROI conversation. When I started the data team at BenchSci, I had a really hard time getting buy-in from leadership to be able to buy tools that we needed. I made the mistake of going and asking for Looker as our first BI tool. Don't do that. You need to show some value first before you can get there. So actually, I gave a talk at Coalesce last year with John, who's sitting right there. We did it on the playbook of like how to stand up your data team. And in that, we talk a little bit about how to kind of get that justification. And our argument was like, start with something low cost and show the value first. So if you can, try something open source, like, or try something like Metabase where it's not going to cost you a lot to run it, but you're going to be able to actually like get some value. And then once you start to get that traction and that buy-in, it gets a little bit easier to make those conversations happen.
Any more questions?
No? Awesome. Okay.
Round of applause for Lindsay.
Ready?
By the way, if you use Snowflake, check out Select. 30 minutes could save you 20% on your Snowflake bill. I'm not joking. Come find me. Oh, yeah. So announcing the Toronto Modern Data Stack holiday party next month. I'm just gonna open the event right now. But if you grab your phones, you can scan this QR code, and you should be able to sign up to RSVP for this event. It's gonna be really chill, guys. It's gonna be low key, okay? No tech talks. We're just gonna have a lot of drinks and food. There will be some VIP guests. Might throw in like a panel interview, but it'll be fun, chill, okay? No hardcore tech diagrams or market maps, promise. Yeah, I think that's more or less it. Yeah, so if you can give us feedback, this always helps. You'll be enrolled to win a $25 Amazon gift card, which we give away every time. But please take a screenshot or take a photo and give us feedback. It really helps us improve. And yeah, that is it. So I think usually we go out for drinks after. Can we stick around for like 10 minutes, 15 minutes if people want to? Yeah. So yeah. So I think we can stick around here for a little bit, and then we'll head over to a bar. We don't have a reservation, but there is a place just down the street called the NBA Courtside, which is a 7-minute walk west of here. So I think we can try to make it into there, and hopefully they'll have space. But yeah, thanks to all our speakers. Thanks to Wave. Thanks to Secoda, and thanks to everybody for coming.